Hello everyone, this is the video of our capstone project, which is agricultural drone. This team comprises of 4 members, Anmol, Bansal, Ankit, Dahiya, Lokesh and Samardeep Singh. This is a group project being completed under the aegis of Thapar University, Patiala, under the guidance and mentorship of Dr. Ashish Purohit and Dr. Neeraj Grover. India is an agricultural country and today is the major exporter of many agro products. It is the need of the hour to repeat the history of the 1960 feet and connect farming with an era of technology and digitalization to achieve the aim of the new revolution. The motivation of this project was that currently, Indian farmers rely on traditional ways of spraying fertilizer and pesticide, i.e., manually using backpack sprayers or using tractor-mounted sprayers, and as these methods depend on human abilities, so the scope of improper spraying increases, and the efficiency witnesses a significant loss. Also, some fertilizer react with the skin and cause skin infections. The number of manufacturers of drones in India is quite high, and even the drone that is available is not suitable for small-scale farmers and costs them an arm and a leg. The agriculture drone is a pre-programmed hexcopter that is provided with a pump and tank, 500 ml, assembly having a replaceable battery which will be easy to use and controlled with the help of an RC system, and the speed of spraying will be adjusted in order to achieve maximum productivity, and the losses will be minimized. It can further be facilitated with cameras that will monitor the farms and farming activity. So here is how we started. Different design iterations. The first design concept set the basic foundation of our project, which lead to further improvements as our design. The basic frame design included 2 hexagonal plates and 6 solid rectangular bars. Earlier we were going to braze rectangular bars with the 2 hexagonal plates, but dropped the idea because the weight that was exceeding our limit and also because the design was quite difficult to construct. The second design was modified in order to optimize the weight of the frame and to make such arrangements that the machining and manufacturability of the frame become convenient. Instead of brazing the rods to hexa plates, we made some jointers which will bind the plates and rods. In order to decrease the weight, we replaced solid rectangular rod with hollow circular rod. It now consists of circular rod, motor holders, hexagonal hollow plates, middle upper jointer, a bottom jointer and a stand for landing will be added to it. At last, this design was finalized for the frame and the final model of our drone was selected. Electronics parts required consist of 6 BLDC motors PF 1000 kV, 6 electronics speed controller, 8 inches propeller, 3 cell 11.1 volts, 2200 mAh, LiPo GPS module, fly sky transmitter and RECIEVER. Moving into the manufacturing zone. Finalized the Creo model for our drone. We visited the mechanical workshop at our campus. There we did the cutting and turning of 6 cylindrical pipes for our arms, drilled the holes for nut bolt to hold plate and holders. We checked the placement of the holders and plates. Assembly started. Weight was checked and it came out 681 gram. For only frame weight reduction was done by removing 1.5 mm of thickness from top and bottom plate by the milling operation. Here is the code for the CNC machining for pocket milling of hexagonal cross section in 3D printing of motor holders was done in the additive manufacturing lab and material used was ABS. Let's move into the connections and calibration part of motors. Circuit diagram of hexacopter connections. Soldering of ESC connection to microcontroller. Using the Mission Planner software for calibrating the motors with our microcontroller. Here is our team.